In this lesson, let's learn about mathematical induction and inequalities. 数学的帰納法、不等式。Let's prove that 2 to the power of n is greater than n to the power of 2, when n is a natural number greater than 4. First, let's prove that with the lowest value we can, when n equals 5. When n equals 5, the left side equals 2 to the power of 5, which equals 32. The right side equals 5 to the power of 2, which equals 25. From that, we know that the left side is greater than the right side. Next, let's assume that n equals k holds true. If n equals k, then 2 to the power of k is greater than k to the power of 2 holds true. Next, let's prove that n equals k plus 1 holds true using our assumption. When n equals k plus 1, the left side equals 2 to the power of k plus 1, which equals 2 times 2 to the power of k. From our assumption, the left side is greater than 2 times k to the power of 2. The right side equals parentheses k plus 1 parentheses to the power of 2. The left side minus the right side is greater than 2 times k to the power of 2 minus parentheses k plus 1 parentheses power of 2. This equals 2 times k to the power of 2 minus parentheses k squared plus 2k plus 1 parentheses, which equals k squared minus 2k minus 1, which equals parentheses k minus 1 parentheses power of 2 minus 2. From k greater than or equal to 5, we know that the left side minus the right side is greater than 14, which is greater than 0. From that, we know that n equals k plus 1 holds true. Finally, from steps 1 and 2, we were able to prove that the given equation is true for all natural numbers greater than 4 using mathematical induction. Now let's do some practice. Press the pause button and try to solve the practice problem. Once you are finished, press the resume button and mark what you got correct. Now let's check our answers. When n equals 3, the left side equals 2 cubed, which equals 8. The right side equals 2 times 3, which equals 6. Therefore, the left side is greater than the right side. If we assume n equals k holds true, then 2 to the power of k is greater than 2k. When n equals k plus 1, the left side equals 2 to the power of k plus 1, which equals 2 times 2 to the power of k. From our assumption, the left side is greater than 2 times 2k, which equals 4k. The right side equals 2 times parentheses k plus 1 parentheses. The left side minus the right side is greater than 4k minus 2 parentheses k plus 1 parentheses, which equals 2k minus 2, which equals 2 parentheses k minus 1 parentheses. From k being greater than or equal to 3, the left side minus the right side greater than or equal to 4, greater than 0, we know that the left side is greater than the right side holds true. From this, we can prove through mathematical induction that the given equation holds true for any natural number greater than or equal to 3. Were you able to answer the question correctly? That concludes this lesson.